problem like I'm in a UFC octagon. This is count collisions of monkeys on a polygon. Okay, so there's a regular convex polygon with n vertices. The vertices are labeled from 0 to n minus 1 in a clockwise direction. Okay, so you have this polygon here with 6 sides. The following figure shows a convex polygon of 6 vertices. All right. Each monkey moves simultaneously to a neighboring vertex. A neighboring vertex for vertex I can be either the right vertex or the left vertex, right? So any monkey that's on a vertex, it can move to the left or it can move to the right. You know, this monkey can move to the left, move to the right. A collision happens if at least 2 monkeys reside on the same vertex after the movement. Return the number of ways a monkeys can move so that at least one collision happens. Since the answer may be very large, return it modulo 10 to the 9 plus 7. Okay. So this isn't really my favorite problem because it's more so just one of those combination, statistics, mathematical based problems that don't really reveal your understanding of data structures and algorithms, maybe just your intuition about the nature of mathematics and how you can use statistics to approach these kind of deals. But I'm not going to run breadth first search or depth first search or dynamic programming or whatever to solve this. There are some fine tunings that we have to execute in order to make this time efficient, and I guess that relates to some computer science topic, but this problem is more so just statistics. Okay, so what is the statistical probability, right? What is the chance? How many times would something happen where you have monkeys, if they could move in either direction, how many times could it occur that they end up on the same vertex? So simply put, the way that this works is I can't even do simple things, man. Okay, apologize for my foolishness. 1, 2, 3, 4, 5, 6. All right, so we have this polygon, right? And we have a monkey at any position. For example, we could have a monkey here. This is my drawing of a monkey. Now, this monkey has an option, right? It can either go to the left or it can go to the right. So that means that at this position, there are 2 options in terms of what can occur. Okay? And really that's true for any monkey, right? This monkey can go 2 to the left, 2 to the right. This monkey can go 2 to the left, 2 to the right. This monkey can go 2 to the left, 2 to the right. This monkey can go 2 to the left, 2 to the right. This monkey can go 2 to the left, 2 to the right. Right? So if you wanted to think about this in terms of the total number of things that could happen, right? Because at each of these positions, there's 2 things that could happen, right? If I would say this was the 0 monkey, the first monkey, the second monkey, the third monkey, the fourth monkey, and the fifth monkey, we could think about the things that they could do, right? This monkey could go left, this monkey could go right, this monkey could go left, this monkey could go right, left, right, left, 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 right, right, right. Right, so these are all the options that the monkey can take. Hence, there's 2 things that could happen. So really, all the things that could happen are just all the string combinations you can get here, right? Which would equate to, well, how many combinations could we get here? We could get 2 to the n. Right? We get 2 to the n because for each monkey, for each n monkeys, right, they can do 2 things. So if you multiply all the things that could happen, there's 2 to the n things that could happen. Right? So there's 2 to the n total possibilities in the system, right? Where the monkey decides that it goes left or the monkey decides that it goes right, right? You could have this monkey decides to go left, this monkey decides to go right, this monkey decides to go right, this left, right, whatever, right? So this is one such case of a choice that could occur if a monkey decided to go left or a monkey decided to go right. So how does that relate to this problem? Well, this is all the possible ways, right? 2 to the n is all the possible ways that you could make a decision, right? These are all the possible decisions that could be made, 2 to the n possible decisions. But we only want the ones where a collision occurs. Well, if this is all the ways that a collision, that something can occur, all occurrences, right, equals 2 to the n. But you could also say that collision occurs plus the number of ways that a collision doesn't occur. Right? This is why this problem is just very statistics based, right? Because this is kind of like, maybe if you're very intelligent, these kind of things are very intuitive. But for someone like me, this is some trick that I've learned from taking a statistics class. Equals all occurrences. Right? This logically makes sense, right? The number of ways where a collision occurs plus the number of ways where collision doesn't occur equals all occurrences, right? Because these are just binary opposites, right? This is all the ways that a collision occurs, so that's some part of the system. This is all the way a collision doesn't occur, so that's some other part of the system that isn't this part of the system, so that will gather all possible ways, right? So then if we wanted the way that a collision occurs in terms of this system, because that's what we're trying to find, that would just be all occurs minus collision doesn't occur. And we already know this information here, that is 2 to the n, right? Because that's all possible occurrence, and we used a little statistical formula to find that. So now we just need to think about, well, the number way of a collision occurs is, well, the number way that all occurs minus the way that a collision doesn't occur. So how can a collision not occur? Well, when we look at this system, a collision occurs if essentially these things run into each other. And what I mean by that is, well, how can we make this so that the monkeys don't run into each other? If this monkey decides to go this way, and the monkey that's on this node decides to go this way, they're going to hit each other. Right? These two monkeys are going to run right into each other. Right? So basically, if any monkey decides to go the opposite direction of any other monkey, there's going to be a collision. Right? Like if all these monkeys decided to go the same way, that way they don't, like, this guy's, if a monkey's here wants to go this way, and this monkey wants to go this way, and this monkey wants to go this way, and this monkey wants to go this way, if this monkey decides to go this way, right, there's going to be a collision. So the only way that a collision won't occur is if no collision, if all monkeys decide to go left, or all monkeys decide to go right. So if all the monkeys decide to go left, then there's no collision because all of them just move like this, right? If there's monkeys in all my fingers' positions, they all just move one over and they don't run into each other. If all the monkeys decide to go right, that means they all move like this and they don't run into each other. But if any monkey decides to go a different direction of any other monkey, it's going to cause a collision at some point. Okay. So basically this only works if everyone decides to go in the same direction, which is pretty intuitive. So there's only two cases, right, where they all go left or they all go right, where a collision doesn't occur. So a collision occurs how many times? All the times except for the two where they all decide to go the same direction. And that's two cases, because they either all decide to go left or they all decide to go right. Okay. So then that is the solution to this problem, 2 to the n minus 2. Now we need to introduce and then we want to mod this at the end by 10 to the 9 plus 7. So this, everything we did here is just statistics, right? We literally just did a statistics problem to solve this, which is kind of annoying because how is that really Leetcode? You know, how is that fair if you got that in an interview? Now, this is the correct answer, but what's problematic is that it's not going to meet the runtime complexity, because you'll notice that, so this failed, okay? You know, time limit exceeded. Why? Well, because we go 10 to the 9, right? So 10 to the 9 squared is going to blow up too fast, and it's just going to take far too long to compute that value. So where this becomes kind of understanding an optimization as well, if you apply a mod, you can apply the mod any number of times as long as you apply the mod at the end. Again, that's another statistical property that you should probably know about. So this problem, I've said enough. But essentially what you can do is if you run pow on 2 to the n and you keep track of the mod that you're trying to use, then it won't scale too fast and it'll be bounded by 10 to the 9 plus 7. Right? So now it's constrained what the value can be, so it won't blow up when it's 10 to the 9. So this basically just specifies the mod value, right? So 2 to the n with this mod. Whoa. Okay. So what's the time complexity and the space complexity of this? Well, we have to do 2 to the n, but we have log n bits that we need to commit on, so that would be big O of log n. And then for space, we just keep constant variables, so O of 1. Okay. All right, this is kind of a annoying problem. If I got this in an interview, I'd be pretty frustrated because it doesn't really articulate my knowledge in terms of data structure and algorithms, more so my knowledge as a statistician. So I don't know, maybe data science or something like that, this might be more applicable, but not for a standard back-end, front-end software engineering role or whatever. Okay. See you guys.